Okay. So for the next question, part C. Okay. A few things to take note when it comes to series. One is your 12 volt for the series circuit 8.3a is being shared by the two lamps. Right? Now the two lamps are identical. So what can you tell me about the potential difference between the two lamps?
Both each of them has 6 volts.
Yeah. Okay. Another thing to take note is the current will be the same for the two of them. Okay, I is the same for the two of them. So these are things that you will need to take note. Okay, can you see on the screen?
Oh yeah.
All right.
Yeah.
So I will be the same for the two of them, and the two of them will have the same potential difference because they are in series and they are the same. Okay, if you are not too sure about this, you can use potential divider rule. All right, let this be R and R. So you will get, let's say for any one of them, for the first one, if you apply the formula, it will be R over R plus R times 12. And that will give you R over 2R times 12. That will be 6 volts. Okay, so this is the reasoning behind why each of them will have the same potential difference.
Okay.
All right, so before we even do the question, these are the things, the basics that you need to pin down. Okay, so for the next one, can you tell me what about the I over here in each of them?
Yeah, 1/6.
No, the two of them are equal. Once again, identical. So the I will be shared equally between the two of them.
Yeah.
And then for the 12 volt over here, you will have potential difference for each of them. What will it be? Since they are parallel, there's 12 volt over here. The EMF is 12 volt. The two of them are connected parallel with the battery. So what do you think is the potential difference? No, for parallel, it must all be 12. Okay, you think about it. For here, they share equally because they are in series. And you use potential divider rule to derive. For here, because they are all in parallel. So the rule is that for any circuits that are in parallel, all the potential difference are the same. So the moment you're connected parallel to the battery, right? Whatever EMF the battery has, assuming that it is an ideal battery with no internal resistance, you will have the same potential difference with the battery. Which means that if the battery is 12 volt and you are the one connected parallel to the battery, you as the resistor must have 12 volt. So these are the basics that you need to pin down before you even do the question. Okay? So with this, we shall go and do the question. Use the information in figure 8.4 to determine the current through the battery. All right? So that's why I say you have to look at the figure first and understand what they're talking about. So straight away for 8.3a, right? Each of them has 6 volt. So you can use the 6 volt straight away to get figure it out. 6 volt is over here. So this is for part 1. 6 volt is over here. Use the good old graphical method. Draw dotted lines up. Very traditional way. The method you have learned since Sec 1, I guess. 2.8 ampere. All right, since both of them are 6 volt, so straight away it's 2.6 ampere. So this one is done. 2.8 ampere. Graphical method. Okay. Now, why is it that we can do this? Because this is the IV characteristics of each lamp. So all you need to do is find the potential difference across each lamp and then use the volt, the potential difference to cross-reference and get the answer out. Based on this, for 8.3b, what do you think is the answer?
4 plus 4.
4 plus 4?
Yeah.
Okay, let's take a look. How do you get 4?
And then the graph, and then 12 volt.
Yeah, so 12 here, so you got 4. Okay, so this one is quite straightforward. There's no need to dotted line this thing because you are directly on the solid line. So straight away, each of them with 4, and then you get 8 ampere as the answer. Okay. All right. So if you have these two, part 2, calculating the total resistance becomes much easier because the total resistance, which is denoted by RT, is the total potential difference or the EMF, okay, divided by the total current.
Yeah.
All right. So for the two of them, the EMF will be the same at 12 volt. So you have 12 volt over here. In this case, it's 2.8. Then you can get answer.
Okay.
Then the other one will be 12 divided by 8. Then you can get answer. That's it.
Yeah.
So, in case you're wondering, like, why not I just use the find all the individual R's? Okay, do I have the resistance? Why not I just use 1 over R1 plus 1 over R2 equals to 1 over R? Why don't I use that? R plus R equals R total. Why don't I use that?
Sure.
Actually, the answer is yes. You can. You can find the individual R's. If you know the potential difference for each of them, you can add up. But that's a lot of work. That's a lot of steps.
Okay.
Whereas this is a one-step thing. So you see, 2 marks, each of them individually will be 1 mark. So you should foresee just getting the answer within a single step. All right. So your other way that you were thinking about is possible, but you will be looking at 3 steps to get the answer. Whereas this is a much cleaner way to get the answer. Yeah. So in case you're wondering, right, few things to take note also lah. The answers here, if you want to keep it in terms of the dP, right? This should have been, so let's keep to 2 dP. Gonna put 8.0. Okay, then whatever answer, you can keep it to 2 dP. Okay, in case you're wondering how many 2 SF. In case you're wondering how many SF should we put, the lowest SF is 2. So your answers given all the SF here are 2 SF. So the values that you get should be based on 2 SF.
Okay.
Okay, if you are given three SF values, then you should be based on that. All right. Lowest SF is 2. Any question?
No.
Okay, we're done for this one.